You're right. With these iPads. My other iPad, they're working on it, and now the camera doesn't work. So they were trying to figure out space and storage, now the camera doesn't work. So we'll see what happens. So anyways, endothermic. I want to write this down again. Endothermic. Gain energy. Gain energy. And what we're going to write here is a positive delta H. And in parentheses, that means a positive heat of reaction. Positive heat of reaction. When you see this symbol, delta H, it means change in heat / energy. So, for example, to go from a solid to a liquid, right? Let's write this down. Solid to liquid to gas. Going from left to right, that is an endothermic process. The solid, liquid, gas are gaining energy here. Solid's gaining energy, liquid's gaining energy to weaken and break those forces of attraction. That's a positive thing, a positive number. So, for example, to go from solid to liquid, let's say this substance has to gain 100 joules, plus 100 joules. So this solid needs to gain energy and turn into a liquid. Again, joules is a unit of energy. This banana has like 450. It's kind of getting bruised here, but this banana has 450 joules. A steak has like 2,000 joules. So I'm just giving you a kind of a point of reference. What the heck does that number mean? So certain solids need energy to weaken the forces and form a liquid. And then to go from a liquid to a gas, maybe it needs 500 joules. Positive. I want you writing this down. It helps understand the concept, and it's going to help you understand table I. Alright? So I'm taking what we've already kind of learned, repeating it, applying it to phase changes a little bit, so you can kind of relate it to table I. That's why I'm doing this. This number here, when I wrote it on the board earlier with the homework, I didn't really do a good job. This number is always bigger than that number. Why? Eyes up here. Solid to liquid, I told you, you're just weakening the forces. They're still really close. But here, like Skylar said, you're breaking. So to break forces, you need way more energy. Try and remember that. Okay, the next few days and then the rest of this unit here, that's important to remember. Okay? But anyways, this is an endothermic process. On table I now, and again, it's different, but it's also the same concept. So I'm trying not to confuse you. I'm just trying to teach what you've already kind of learned. Let's apply it to something new, but it's not that new. If you look at any reaction on table I and then look to the right, you have a delta H as the heading. Okay, if you look at the very top reaction, under delta H it says negative 890.4, and the unit is kJ, which is kilojoules, not just joules. That's kind of like kilometers or kilometers and meters. So if you keep moving down, all the way down, what's the first positive number you see? What's the first positive number you see? What is it? 182.6, right? Everybody got that? Put your finger right on that, please. Okay. What does that mean? Based on what I just told you behind me here. What does that positive 182.6 mean? Kiki. Very good. Yeah, that's good for now. This reaction, look to the left, N2 plus O2 yields 2NO. That reaction cannot happen unless it gains 182.6 kilojoules of energy. Okay? And that may not mean a whole lot to you, like what is that reaction? I don't get it. All I need you to learn today is how to read this table. That positive 182.6 means that reaction to the left cannot happen. If I want to do that reaction in here, in lab, with gases and fancy equipment, it will never happen unless I give it 182.6 kilojoules of energy. That's what that means. And that's what endothermic means. Processes that gain energy. This could be a physical or a chemical. Table I kind of shows both. Okay? Look up here again. Right here, this is an example of physical change, phase change. Table I, this reaction we're looking at, your fingers on it, that's a chemical change. But both are positive energy numbers. So that means endothermic. So I guess really what I'm trying to get through today is what's that word mean, and then how are you going to see it on paper? Positive values for that, delta H. Okay? Delta H just means the change in energy. So now exothermic is exactly the opposite. So we're going to write the same notes, just the opposite here. So exothermic, okay, exothermic here, release or give off energy, right? And it's going to be a negative delta H, which means, actually I don't even need to label it. The labeling's the same. It's called heat of reaction, change in energy. I don't need to write the same notes. But negative in front of it means we release energy. It's losing, getting rid of. And the example would be gas to liquid to solid. So to go from a gas to a liquid, the value of delta H would be negative 500 joules, and the value of this one would be negative 100 joules. So to go from a gas to a liquid, it's got to get rid of that energy it already gained. And then it has to get rid of even more to go down to a solid. The negative sign doesn't mean the number is actually negative. The negative just means for you to understand it's being released. There's no such thing as negative energy. That means it wouldn't exist. Okay? So, again, this sign is just to indicate energy is being released, not that it's a negative number. I know that might be confusing. Look at the very first reaction. It says negative 890.4 on table I. Negative 890.4. So in order for that reaction to occur, it has to get rid of negative 890.4. Now I'm going to rephrase this. That first reaction, after it reacts, it gets rid of 890.4. That's how these exothermics work. They react and then they get rid of the energy. If you go back to that positive 182.6, it works exactly the opposite. It needs to gain that 182.6 before it can actually react. So this is different. It happens after the reaction, whereas endothermic happens before. It has to gain the energy beforehand. Okay? So once the gas condenses, it releases energy. Once the liquid forms a solid, it gets rid of the energy. To go the other way, it needs to gain that energy first to melt and then to evaporate. So the concept here is what's the order of events. This is always after the reaction, and then the endo is always before. And that's kind of the last thing I'm going to end with here. So using this information, we need to be able to write reactions down on paper. What does that mean? Here's what it means. Using table I. If you're really trying to pay attention, and I know it's not super exciting, I don't have animations or demos or whatever, you're just taking notes, listening to me. But if you're trying to listen to what I'm saying, see if you can figure out which one is correct. Okay? Using table I. Which is correct? Alright, I'm going to write a reaction from table I, and I'm going to write it two different ways. Here we go. Let's go with this one. Okay, you got N. So write exactly what I write. N2 gas plus 2 O2 gas yields 2 NO2 gas. And then I'm going to write the exact same reaction underneath it. Sometimes my G's start looking weird because I don't really make the loop there, so hopefully you get used to that. Those are all gases. Okay. First things first, and I'm going to end with this. If you look this reaction up on table I, Bella, can you tell me if it's endothermic or exothermic, according to what we just learned? Forget what I have on the board, look on table I. So find this reaction on table I, and then tell me why you know it's endo or exo. You say it's endo, why? But what on table I tells you that? You're right, it is endothermic. What on table I tells you it's endothermic? Phone a friend. Call someone out. Kira. The plus in front of the 66.4. So if you go to this reaction and look to the right, you see positive 66.4. So I'm trying to get you to get this here today. I know we're out of time. The positive number means this is gaining energy. Look at the very bottom of table I. I'll stop there and we'll continue with this tomorrow. Look at the very bottom. Very bottom. What does it say? A minus sign indicates exothermic. It tells you the answer. All the minus signs are exo, all the positive are endo. Okay? We'll pick up with this tomorrow, and that's it. Does anybody need, if you need to see me after school, let me know before you leave class today, so I can plan what I'm doing later. Don't forget that review sheet if you want to do it ahead of time. I'm reading the answers tomorrow, or you can just copy the answers down tomorrow and then do some of that and check yourself, right? You can do that.